So good afternoon, and thank you to Rick and Peter and SMPTE for inviting me to come along today and talk about machine learning and AI for QC in media files. So I'm Dom Jackson with Telestream, and among other things, I'm responsible for some of our QC offerings. So I'll talk a little bit about what we mean by QC, talk a little bit about what we mean by machine learning and artificial intelligence and why I hate the term artificial intelligence. I'll talk about how ML systems can apply to QC specifically. I'll talk about the issues around training machine learning systems a bit, look at the current situation, what's out there today that we can use, talk about where that might go in the future, and touch a little bit on some aspects of ethics and economics. So what do we mean by QC? Well, it turns out when you talk to people in the media industry, they mean all sorts of different things by QC. My definition is that to QC a media file is to verify that the file you have is fit for your purpose. So you may need a pristine file for archive, you may need a file that's compliant for DPP delivery in the UK, you may be interested in looking at visual defects or audio channel mapping. It can be a host of different things. So in a little more detail, we can talk about container checks. Do I have a ProRes QuickTime file? Is that what I wanted? Metadata checks. Do I have captions? Do I have the right descriptive metadata or EPG metadata? Is the coded bitstream valid? And then a whole host of checks on the video and audio uncompressed baseband, which is probably where ML is going to shine. And then things like program layout checks. Have I got a black slug where I expected a black slug? Have I got bars where I wanted bars? We can also talk about QC in terms of manual, automated, and hybrid systems. So obviously, manual, traditional QC station, someone's looking at video. Automated, ideally no human required, the machine makes the decision. And a hybrid system where the machine is potentially pointing manual QC operator to areas in the content where there may be problems and allows the human to make the final decision. And particularly when we're talking about AI or ML, what we're really talking about probably is taking problems that were traditionally in the manual space and moving them into the assisted space. All right, so we talked about what QC means. Now what do we mean by AI and machine learning? So Logan gave some great definitions of the various kinds of AI, which I guess I'm going to recap a little bit here. In broad terms, an artificial intelligence system is any artificial system that behaves intelligently in a given situation. That's sometimes called the weak AI hypothesis. But AI doesn't have to be very intelligent. I can write a tic-tac-toe algorithm in 5 lines of code that plays a perfect game of tic-tac-toe every time and will cause a draw with a chess grandmaster every time. So on that footing, it's intelligent at tic-tac-toe, but nothing else. And the other question we always have when we use the term AI is what do we mean by intelligent? Another interesting nugget that I came across as I was looking at this in the last few weeks is you talk to people who work in AI, and they have this definition of AI, which is anything that we haven't done yet. Because as soon as I have a technology that was AI because it was challenging, like OCR, now OCR is ubiquitous, right? And nobody calls that an AI problem anymore. It's just a technology. And then as Logan alluded, we have this thing called artificial general intelligence or true AI. And I think this is where we're talking about intelligence that approaches that in breadth of a thinking animal or an intelligent animal. A lot of people think that's what AI means, and I would contend they may be right. But I think beyond that, we'll leave that to philosophers and sci-fi writers. So does that help me QC media? Not really. All right, so what about machine learning? So it turns out machine learning is a much easier thing to define. Tom Mitchell wrote the book, Machine Learning, so he should know, and he came up with this very succinct definition of what he thought machine learning was. I'll make it even more succinct and say that it's an automated system that can learn to perform a specific task or set of tasks. So that sounds more promising. So let's talk about why machine learning might be useful for media QC and indeed a whole host of other things. Firstly, it turns out that ML systems are really good at solving problems that are really difficult to solve by writing code, if not impossible. I challenge anybody to write code to recognize that that face is Anderson Cooper. You can't do it, right? Or if you can, I'm amazed. So in general, we're talking about the ability to automate tasks that could previously only be successfully done by humans. And in general, ML systems can perform those tasks faster and with fewer errors than humans. Machines don't get tired. So there are many media QC tasks that turn out to be highly amenable to ML approaches. Language validation, text positioning. People have touched on a lot of this stuff before in different contexts, but this basic information that we can extract is very useful for all these kind of QC processes. But if we just talk about needing to build a machine learning system to solve one of these problems, there's an issue here, and that is that machine learning systems need to be trained. And that training, again, as Logan alluded to, can be very, very expensive. And the reason is because you typically need large and pre-classified data sets. So if I want to teach an ML to find a cat in an image, I need lots of images with cats, and ideally lots of images without cats, and a human being has to sort those all out, and then we have to feed them into the ML until it can learn to spot what's a cat and what isn't. There are some ways we can mitigate that issue and that expense. One of the ones is that we can use existing data sets. So if I want to train an ML to do speech to text, it turns out there's an awful lot of transcribed audio out there already. You know, every court proceeding, every police interview, you name it, all the caption content out there can be fed in to an ML system and used to help train. We can also sometimes generate artificial data sets, but there are some definite risks in that you can end up teaching the ML to spot something that's characteristic of your simulated error or whatever, rather than the real error. So can be used with caution. And of course, actually what happens in the real world is we just find something that someone else has already trained for us and use that. So there's very good trained ML systems out there today that can do speech-to-text conversion, automated translations. You know, you've all used Google Translate. A lot of those systems now are beginning to be able to actually automatically recognize languages, and that's huge in any environment where you're doing multi-language workflows, and you can't have a native speaker for all of your languages on staff when you've got 32 languages that you're dealing with, or whatever it might be. So to be able to tell it's, Danish or Swedish is kind of useful. Text recognition in a QC context, particularly being able to look at the position of text on the screen, is important. You want to have, you don't want to make sure your graphics aren't going to occlude on-screen text and things like that. There's a general class of object recognition that has some use in QC, but perhaps not as much as it does in other things like searchability. And there's actually been a good deal of work done specifically on detecting inappropriate content, nudity, profanity, that kind of thing, specifically in images and video and audio. As has become abundantly clear from a number of the presentations today, most of the machine learning systems that are practical and used today are cloud-based. A lot of that's because it's those guys that have the money to build these systems and train these systems. And most of these systems aren't in any way, shape, or form aimed at solving QC problems. It just happens that they can provide information that can then be processed to help automate a QC process. So, auto-transcription just gives you words and timings, but then it's up to us to take those words and timings and build the layer on top that actually correlates that with the captioning and checks that the captioning is valid and looks at the sync between the captioning and the audio. Again, there was some reference to how you can feed back information into the ML that you're using to make it better. And obviously, if you have a cloud deployment like that with hundreds of thousands of people using that service for different things, if there's a feedback mechanism, then all the feedback all those users provide benefits everybody by making the ML system better. And of course, as always, when we talk about media in the cloud, for some people, moving large files or keeping all of their large media files resident in the cloud is fine. There's still an awful lot of people who have a problem with pushing, huge media files into cloud storage, or pushing huge media files into the cloud specifically for the purpose of having them analyzed when they're already keeping them on their local storage. So, there's some pros and cons there. So I took a little look around at what's out there today that we can use. There's really, 4 major cloud providers out there. We've got Amazon, and they can do speech to text, and they can do text translation, and they can do various kinds of visual recognition, and they call out that they have text recognition and inappropriate content detection. We got Google. They can do speech to text. They can do text translation. And they can do various kinds of visual object recognition, including inappropriate content detection. IBM Watson, also speech to text, text translation. Some of you may be spotting a trend here. And visual recognition. And finally, Microsoft, again, with the same basic set of functionality that we can apply to QC problems. My not very stunning predictions for the future. We're going to see these existing cloud-based ML systems continue to improve and add new capability. It's worth noting that we're in a bit of an arms race around these functionalities right now. And you take an example like speech to text. IBM may be doing really well on Brazilian Portuguese this month, and Azure might be doing really good at Scots accented English, and then they'll keep leapfrogging each other over time. There is now, again, has been alluded to, the ability to take some of these models that were trained in the cloud and move them down into on-premises systems, even as far as moving them into mobile devices for some applications. And again, that's still going to be important for people who don't want to push their media into the cloud. The flip side of that, of course, is that as media workflows move into the cloud, more and more people are going to be able to leverage cloud-based services. And we have this whole true AI, this HAL 9000 kind of intelligence, and who knows where that's going to lead us. We'll leave that to, as I say, the philosophers and the sci-fi writers. I think it behooves anyone who's engaged in the process of automation to think about, well, obviously we all need to think about the economics of things, but also the ethics. Sometimes we're automating processes that simply didn't get done before. A lot of the time, there's somebody behind the scenes going, aha, I'm reducing my personnel costs. It's just something I think we should all acknowledge when we're engaged in these things. Flip side of that is that anytime you're automating human processes, it's much less attractive in markets where labor is cheap. So you might find that you can go out and sell the heck out of a machine learning-based AI system in North America, but it might be a different proposition in other parts of the world where they can easily throw people at problems. The other issue, when we look specifically at media QC, is that it's a fairly small market in global terms, and if I have a QC problem that I know I can solve with ML, it may actually not be economically viable for me to invest the money in training and building the ML for that specific problem if it's very specific to, say, a media QC space. So a few conclusions, and then we can all get to ice cream. Stop calling it AI. It's machine learning, or at least that's my opinion. There's a lot of useful existing ML systems out there that we can use for QC. They're going to continue to improve. And it's not always a given that an ML solution is going to make economic sense, even if we know we can do it technically. And with that, questions or ice cream, your choice.
We're a little ahead, so we have, I think, some time to take questions. And if anyone wants to throw their hands up, I have one for you, Dom, because I always have questions. A lot of people who have talked about machine learning / quotes AI today, there's a few words that keep coming up: training and teaching. And I also have heard, just separately, one of the interesting things about training these types of systems is that it can often be very difficult to reverse engineer what the algorithms have sort of come to after these training activities.
Oh, absolutely. You have no idea what's going on in that black box.
So here's the question. What actually do you mean? What are we talking about when we're talking about training or teaching a piece of software? Personally, I've heard of a thing called a neural net. I don't really know much more than that.
Yeah, and a neural net is one of the models or techniques that gets used for learning, and it's so called because it's based on the idea of the way a human neuron in the brain works, which is basically doing a weighted sum of inputs. There's also many statistical techniques that people bring to bear, and I wouldn't claim to be an expert on the detailed algorithms. But when it comes down to it, the training process, we'll go back to my cat analogy, I have this neural net, and let's say I've got an input for every single pixel in an image, and I have a whole sequence of images, and I give the image to the system, and I say this one has a cat, and then I give another image to the system, and I say this one doesn't have a cat, and eventually I'll be able to give an image to the system, and it'll say cat or no cat. But again, we don't know what's going on in the box.
It could be a bunch of gnomes.
It could be. Yeah, who knows? There was an interesting case a few years ago I read about where someone implemented one of these things on an FPGA, and this FPGA was basically being structured by this AI system or this learning system, and when they looked at it, they realized that there was a whole section of the FPGA that wasn't electrically connected to the rest of it. But when they took that piece out, it stopped working. So yeah, it was making use of some electrical interaction that was nowhere in the design of that chip. You really don't know what's going on.
From a QC perspective, machine learning is something that could easily be applied, but it's not so much recognition. Recognition is not really machine learning. It's more the relationship between what is considered the problem that you're solving, discovery of an anomaly. So wouldn't you agree that in QC that it's not just a question of figuring out what the anomaly is, but what the anomaly represents, and that machine learning would be appropriate for that application?
It doesn't always mean that you need to understand what the anomaly represents. The fact that there is a visual anomaly in and of itself may be sufficient for you to say this isn't good or this needs to go get edited or whatever. Does that answer the question? I'm not sure.
Gary anticipated a question that I was mulling over while you were presenting relating to QC and monitoring by exception. It appears to me that that's one thing a human being can do who understands content, whether it's an editorial decision that the light should be this low or that you'd have a flash in the screen that is supposed to be there because it's a gunshot, or, as opposed to some kind of other glitch, or even an image within an image where you're showing a TV screen or an image within there that is supposed to be distorted. So that could throw off so many exceptions that the editor could find it useless because they'd have to keep going over it manually anyway.
Yes, I mean, in any process, and this isn't only ML, but any process that's even remotely similar to this, you know, we always have a false positive problem, right? You know, whether it's a QC algorithm that's been developed, you know, that's an ML, or you know, whether someone's written code to try and spot macro blocking in an image, you know, that brick wall in the background can throw you off. So generally speaking, whether it's ML or more conventional QC techniques, part of the process involves making sure that you have an acceptable false positive rate. And that in itself can be very time consuming because you have to put huge amounts of content through, look at every positive that gets generated and decide whether it's false or not.
Does it learn every time you go through and checking? Sorry, the follow-up question is that, so you've got a number of false positives you're going through. So I guess you need the feedback from the person who's QCing the exceptions by the monitoring system and then saying, oh, this was okay, this is not okay. And next time it won't throw off those same exceptions.
In an ideal world, yeah, ML systems should never stop learning, and when people start to use them for real, there should be a feedback loop so that you can tell it when it's made a mistake and improve its processing and performance. Yeah.
So I have a comment on that point.
Okay.
Having been down this road, several dozen steps, and right now, for us, a big part of what we're trying to do, or we would like our QC systems to do, is to tell us what issues are in the video, because we are migrating dozens of different videotape formats and film formats and stuff like that. And there are some things where we want it to trigger on, you know, the difference between quad banding and tracking on a 3/4 inch, or tracking on a Betamax, or tracking on a Betacam, or, you know, whatever. Something that will, you know, break a migration, but without a human, you know, paying attention to it. We can't catch it right now, and it may go into the archive and we'll never know about it, or until, you know, decades later we won't know about it. And so one of the problems we found testing vendors already is that the state of the art in recognizing issues like macro blocking, some folks have already done macro blocking and they're doing a decent job of it, but ask it to tell the difference between a camera flash and a flare on a light and a plume from the space shuttle, and it triggers on all three of those and gives you the same error. And you, at this point, I have not met something that can tell me the difference between quad banding and 3/4 inch tracking issues. And, you know, it will be interesting for us to see where this goes, because this at least gives us a prayer. The state of the art for the last 12 years that I've been working on this is that there is no system today that can reliably trigger on any videotape issues, regardless. Any scanning issues other than, you know, black versus presence of video. Beyond that, and maybe some macro blocking, and that's it. And this at least looks like it has a prayer of telling the difference between quad banding and regular tracking.
It has a prayer if you're prepared to invest the time.
And given that we're 250,000 hours into our migration out of a 7 million hour migration, or 7 million item migration, those of us, you know, who have things like that, and, you know, major content, you know, owners like maybe CNN and ESPN and folks like that, I would think that they would be motivated. And especially those of us who can learn and then pass those, you know, learning sets on to folks.
Yeah, I mean, but again, it comes down to somebody somewhere who understands. I mean, probably, I certainly don't know visually what those various artifacts look like. So you need somebody who understands that to sit down in front of this content and say, okay, this problem is here, this problem is here, this problem is here. Or maybe sometimes if you can automate the system of screwing up the playback in a particular way,
create things.
To you know, I introduce a known error, and then I teach the ML what that looks like. That's somewhat more efficient.
So one of my nightmares is that when I retire, I will be hired as a consultant to do that. To do nothing but that for the last 20 years of my life. Thank you.
Thank you. Okay. Thanks, everybody.